Hello everyone. Having discussed alcohols, now we are focusing on the phenols. So in this chapter we'll discuss what is phenol and its methods of preparation. So starting with the heading that is phenol. Now, phenols are those organic compounds in which the OH group is directly attached to the carbon of benzene ring. OH group is directly bonded to sp2 hybridized carbon of benzene ring. So those compounds in which OH functional group is directly attached to the sp2 hybridized carbon of benzene ring, these are known as phenolic compounds or phenols. So we have look at this. So this compound is known as phenol. We can have some other compounds like, look at this. In which we have two OH groups here. So this is 1,2-dihydroxybenzene. Which is commonly known as catechol. We have looked at this 1,4-dihydroxybenzene, which is commonly known as hydroquinone. We can have look at this OH group with methyl substitution and ortho position. It is orthomethyl phenol, or this compound is commonly known as cresol, orthocresol. We have look at this methyl group at meta position is known as metacresol. We have OH group at para position. We say this is teracresol. We have OH and COOH at ortho position. This is known as orthosalicylic acid. Similarly, we can have look at this CHO group at ortho position, orthosalicylaldehyde. So if you look at this, these are all phenolic compounds in which the OH group is directly attached to the sp2 hybridized carbon atom of benzene ring. So this is what we call as phenols. So whereas in case of alcohols, the OH functional group was bonded to sp3 hybridized carbon atom of alkyl group. Then we said that was alcohol. So in phenols and alcohols, the functional group is same, but the difference is the group should be attached to sp2 hybridized carbon atom of benzene in case of phenols, and in case of alcohol it was attached to sp3 hybridized alkyl group. So this is the difference between phenols and alcohols. So after this phenol, definition of phenol, now we comes to the general methods of preparation of phenols. So let's start with general methods of preparation. First method, this is a reaction which is known as Dawes process, a Dawes method. In this Dawes method, we start from chlorobenzene. Now this chlorobenzene is fused with sodium hydroxide under vigorous condition, that is high temperature of 300 degrees centigrade and high pressure of 300 atm. So fusion of chlorobenzene with sodium hydroxide at high temperature and high pressure condition gives you sodium salt of phenoxide. This sodium salt of phenoxide on acidification gives you phenols. So sodium salt is formed because first phenol is formed. Phenol being acidic is again reacted with sodium hydroxide to give you phenoxide. This phenoxide on acidification gives you phenol. Now this reaction is occurring through benzene intermediate. Second method, that is from benzene sulfonic acids. So we have started from benzene sulfonic acids. Now these benzene sulfonic acids again on a reaction with sodium hydroxide. So look at this, we have acidic hydrogen react with base, so this gives you sodium salt of sulfonic acid. Now this sodium salt of sulfonic acid on the reaction further or fusion with sodium hydroxide, the sulfonic group is replaced by OH group. So we say sodium salt of phenoxide. This sodium salt of phenoxide on acidification gives you phenol. So we have this phenol. So simply look at this, fusion of benzene sulfonic acid with sodium hydroxide followed by acidification gives you phenols. Third method of preparation of phenol, that is decarboxylation of phenolic acids. Suppose we have look at this. This compound. Now this compound on the reaction with soda lime, NaOH plus calcium oxide, which is known as soda lime. So heating of this compound with soda lime undergoes decarboxylation, when this gives you phenol. So we have this orthosalicylic acid. Orthosalicylic acid on heating with soda lime undergoes decarboxylation to give you phenols. Then we have nucleophilic aryl substitution. By nucleophilic aryl substitution we can also prepare phenols. So look at this reaction. So we have this aryl halide These aryls are very difficult to undergo nucleophilic substitution reaction. As I have explained earlier, this chlorine is bonded to sp2, so bond becomes strong, so this is difficult to break. Second, due to resonance, carbon-chlorine bond appears to be double bond. Again, bond strength increases, so difficult to break. Second, this benzene cation does not form because this is very unstable, so this cannot undergo SN1 reaction. Next, benzene ring is a nucleophilic in nature due to presence of 6 pi electrons. So these nucleophile cannot be approached by another nucleophile. So normal nucleophilic substitution reaction does not take place. But look at this. If this benzene ring contains electron withdrawing groups at ortho and para position, then substitution reaction takes place by a mechanism known as aromatic nucleophilic substitution reaction. So we introduce NO2 here. Now when this is fused with sodium hydroxide at 300 degrees centigrade and 10 atm, we get nitrophenol. But if we introduce second nitro group at para position, again fusion with sodium hydroxide at 300 degrees centigrade and 9 atm, we get substitution here. So we have OH. So if you look at this, condition is becoming mild. And if we have 3 NO2 group at ortho and para position, then this on warming with sodium hydroxide, just warming, this cell is easily replaced by OH group. So this is by a mechanism known as nucleophilic aromatic substitution. Nucleophilic aromatic substitution reaction. Then we have next, that is by Grignard synthesis, means synthesis by a Grignard reagent. Grignard synthesis. So as usual, the starting compound is Grignard reagent, but we can also start from halobenzenes. Halobenzenes react with magnesium in presence of dry ether to give you Grignard reagent. So look at this. We have this halobenzene. This reacts with magnesium metal in presence of dry ether when we have aryl magnesium halide. So we are actually starting from this Grignard reagent. So this Grignard reagent reacts with oxygen from air, that is aerial oxidation. A reaction of Grignard reagent with oxygen from air, this gives you peroxo compound. These on further reaction give more amount of Grignard reagent, when this gives you followed by acidification, this gives you phenol. So synthesizing Grignard reagent on aerial oxidation with oxygen from air followed by a reaction with Grignard reagent. Then is Grignard reagent must be taken in excess quantity. When this gives you salt of phenol, which on acidification gives you phenol. So this is what we call as Grignard synthesis. Next, that is from cumin, that is commercial method, industrial method. Industrial method, that is from cumin. So starting compound is cumin here, but we can start from benzene. Benzene reacts with propene in presence of AlCl3. So reaction of benzene with this in presence of AlCl3 reaction is Friedel-Crafts alkylation reaction when we have isopropyl benzene. This isopropyl benzene, this is known as cumin. So we have to start from this cumin. So alternatively, cumin can be prepared from benzene and propene by alkylation reaction, Friedel-Crafts alkylation reaction. So the steps involved, in the first step we have this cumin. Cumin reacts with oxygen from air, that is aerial oxidation. Now cumin on oxidation with air gives you cumin hydroperoxide, that is cumin hydroperoxide. This cumin hydroperoxide on acidification undergoes a rearrangement to give you phenol and a very important industrial compound, that is acetone, as a byproduct. So in the second step we have this cumin hydroperoxide. This cumin hydroperoxide is treated with H plus ion, that is acidification. When this undergoes a rearrangement to give you phenol and a very important byproduct, that is acetone. That is byproduct, which is acetone. So this is a very important method for preparation of phenol. Why? Because this byproduct acetone is a very important organic solvent. So during the preparation of phenol, acetone is also formed. So this acetone can be separated from this phenol by distillation process, and we are adding a very important organic solvent. So this is steps of preparation of phenol from benzene, or we say from cumin. The first reaction is with aerial oxidation. When this gives you hydroperoxide, so this hydroperoxide on acidification gives you this phenol and acetone. Then we have next reaction or next method of preparation. Let me just give you the mechanism of this rearrangement. Mechanism of rearrangement. Mechanism of rearrangement. So I'll give you this step of rearrangement in second step. So we have cumin hydroperoxide this reacts with H plus ion. Now look at it, this oxygen is having 2 lone pairs of electrons. So oxygen with lone pair of electrons is acting as a basic site. So this reacts with acid to give you this species OH2 with a positive charge. In the second step of this, we started from this. This undergoes elimination of water. When this gives you electron deficient oxygen, this is undergoing a simultaneous step, but I am showing you in a different step. In the third step, this undergoes phenyl shift from carbon to, now look at this phenyl with each lone pair migrates from carbon to oxygen. Phenyl group migration from carbon to oxygen when we have positively charged carbon, and phenyl group migrates to oxygen. In the third step, now this is resonance stabilized because we have this oxygen, so oxygen can stabilize this cation by resonance. In the next step of this rearrangement, we have this CH3 positive O phenolic group. This reacts with water which was liberated in the B step. So look at this again, the reaction is nucleophile. So we have electrophile. This electrophile is attacked by nucleophilic oxygen when we have this CH3O with a positive charge on oxygen. In the next step of this rearrangement, this positively charged oxygen takes up electron from OH bond, and this releases H plus N, and this H plus N attacks this oxygen when we have CH3C, CH3OH, OPH with H plus N here. Now, in the next step of this rearrangement, we have, look at this. This electron is transferred between carbon, oxygen, and this electron goes with oxygen. So we have this phenol, we have formed phenol from this part, and this is converted into acetone. So this is how this rearrangement takes place. So if you are asked to write the mechanism of this rearrangement, then you have to proceed by this mechanism. If only say write the steps of preparation of cumin from phenol from cumin, then just write down this. But depending on question, if question involves around more marks, then you have to show this mechanism. So this is how this phenol is prepared from cumin or from benzene. Then we have one more important method of preparation. and that method is by distillation of benzene diazonium salts. Steam distillation of benzene diazonium salts. So we have benzene diazonium salt. This is benzene diazonium ion. Now this on steam distillation. Reacted with steam, when this gives you phenol is formed and nitrogen gas is evolved. Now this benzene diazonium ion these can be prepared from aniline by reaction with nitrous acid, or this is a mixture of sodium nitrite plus HCl between 0 to 5 degrees centigrade. So aniline on diazotization with sodium nitrite or HCl or nitrous acid gives you benzene diazonium ion, and these NH2 can be prepared from nitrobenzene. So nitrobenzene on reduction with tin HCl. So nitrobenzenes on reduction with tin HCl gives you aniline. Aniline on diazotization gives you benzene diazonium. And this nitrobenzene can be prepared from benzene itself. So benzene on nitration with a mixture of nitric acid and sulfuric acids. So benzene, nitration, nitrobenzene on reduction, aniline doing diazotization, benzene diazonium on reaction with steam gives you phenol. So this is from benzene diazonium salt, but we can also start from this benzene also. So this is how we prepare diazonium ion from benzene. Or if question says just write a step from diazonium salt, then we have to react with this steam. So this is known as steam distillation of benzene diazonium. So these are the methods by which we can prepare phenols.